We can determine how fast an object is moving by calculating the gradient of its distance time graph. Remember that a distance time graph shows us how the distance travelled by an object changes over time. The x value tells us how much time has passed, and then the y value tells us the total distance travelled after this time. The shape of the graph also gives us information about the journey being described. Specifically, the steeper the graph, the faster the object must have been travelling. We can actually use this idea to calculate a speed using the gradient of the graph. But how does this work? Remember that to calculate a speed, we need to take the change in the distance travelled, which is the change in y values on our graph, and divide that by the change in time, which would be the change in x values from our graph. Recall that when we divide the change in y values by the change in x values, we're calculating the gradient of a graph. So this gradient is equal to the speed. You won't need to explain why there's a link between gradient and speed for your exam. However, most exam questions which ask you to calculate a speed from a graph like this one won't tell you how. This is a relation you need to understand or be able to remember yourself. Let's practice using this technique with an example. The distance time graph below shows the journey Minal takes on a normal day. Use the graph to calculate the highest speed Minal travels at during their journey. Give your answer in kilometres per hour. So for step 1, determine the part of the graph where Minal travels the fastest. Recall that the steeper the graph, the faster an object must be travelling. So for this example, we want the steepest part of the graph. As we can see, that would be this middle section of the graph here. In step 2, choose 2 suitable points on the graph. When calculating gradients, we should choose 2 points that are easy to read and far apart from each other. This will make our calculation as accurate as possible. Let's choose our first point to be here, where we can clearly see that the time was 0.35 hours and the distance was 1 kilometre. Then for the second, let's choose this point, far from our first. Here, the time was 0.55 hours and the distance was 3 kilometres. You didn't have to choose these points in particular. Any 2 points are fine as long as you get an accurate answer in the end. Also notice that we're working in terms of hours and kilometres instead of seconds and metres. That's because those were the units given on the axes of this graph and what the question expects our answer to be in terms of. In step 3, find the difference between the 2 distances. The 2 distances at the points we chose were 1 kilometre and 3 kilometres. So 3 minus 1 equals 2 kilometres. In step 4, find the difference between the 2 times. So the times at the points we chose were 0.35 hours and 0.55 hours. So similarly, we do 0.55 minus 0.35, which equals 0.2 hours. Finally, in step 5, divide the difference in distance by the difference in time. If we wanted to, we could have done the steps of finding both differences and dividing them all at once, but this way we take a little extra time to make our working clearer. The differences we found were 2 kilometres and 0.2 hours. So we divide 2 by 0.2 to get a speed of 10 kilometres per hour. Notice that these units match what the question required, as we divided a distance in kilometres by a time in hours. It's always best to double-check all the units match.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!